Everything you were taught about Jupiter is incomplete. It's not just a giant ball of gas. It's not just a bigger version of Earth with clouds. Jupiter is something far stranger, a world made mostly of liquid. And deep inside, it may be an ocean of metallic hydrogen, a substance so extreme it barely exists anywhere else in the universe. Today, we're diving beneath Jupiter's clouds to uncover what this planet truly is. Humanity's first close look. In 1974, NASA's Pioneer 11 sent back the first close-up images of Jupiter. A few years later, Voyager 1 captured moving images as it flew past in 1979. The planet looked majestic. Swirling storms, colorful bands, massive clouds. But appearance can be deceiving. Those images raised more questions than they answered. What is Jupiter really made of? And how did it grow so enormous? A planet beyond scale. Jupiter is difficult to comprehend. It contains more than twice the mass of all the other planets combined. You could fit around 1,000 Earths inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. And here's something incredible. If Jupiter had been about 80 times more massive, it could have ignited nuclear fusion and become a star. It's often called a failed star, but that description doesn't fully capture its reality. How did Jupiter form? Scientists proposed two main ideas. Theory 1, a massive rocky core formed early in the solar system. Its gravity pulled in huge amounts of hydrogen and helium gas, building Jupiter layer by layer. If this were true, Jupiter should have a dense, solid core at its center. Theory 2, Jupiter formed directly from a collapsing cloud of gas, similar to how stars form, but without enough mass to ignite fusion. In this case, it might not have a traditional solid core at all. For decades, the first idea was widely accepted, but new evidence has complicated the story. The rare impact that changed everything. In 1994, something extraordinary happened. The comet Shoemaker-Levy 9 broke apart and collided with Jupiter in over 20 separate impacts. This type of event may only happen once every several thousand years. Each fragment struck with unimaginable force. The largest explosion released energy equivalent to hundreds of millions of nuclear bombs. The Hubble Space Telescope observed massive dark scars in Jupiter's atmosphere, some larger than Earth. At the same time, NASA's Galileo spacecraft was approaching the planet. Galileo passed through the aftermath and analyzed material from deep within Jupiter's atmosphere. One surprising discovery: significant amounts of water that changed scientific assumptions. Enter Juno. To truly understand Jupiter's interior, NASA launched Juno spacecraft in 2011. It arrived in 2016 and began mapping Jupiter's gravity, magnetic field, and internal structure with unprecedented precision. And what it revealed was astonishing. The cloud layer, just the surface. Jupiter's upper clouds are colder than minus 100 degrees Celsius. Water ice mixes with ammonia, which acts like antifreeze, allowing liquid droplets to exist in extreme conditions. Lightning storms rage constantly, some far more powerful than those on Earth. But these clouds, dramatic as they appear, are only about 50 kilometers thick on average. That's just the skin of the planet. The Great Red Spot. Great Red Spot is the most famous storm in the solar system. It has been observed for over 350 years. At one point, it was large enough to swallow Earth whole. Today it is shrinking, but it remains enormous. This storm extends hundreds of kilometers deep into Jupiter's atmosphere. Ultraviolet sunlight interacts with chemicals in the storm, giving it its distinctive reddish color. Imagine a hurricane that has lasted longer than modern civilization. From gas to liquid, as you descend beneath the clouds, pressure increases dramatically. About 1,000 kilometers down, hydrogen gas transitions into liquid hydrogen. This isn't like an ocean on Earth. It's a superheated ocean of compressed hydrogen, thousands of kilometers deep. Temperatures exceed 1,000 degrees Celsius. Yet it remains liquid because pressure raises its boiling point. Jupiter is not simply a gas giant. Most of its interior exists in liquid form. Metallic hydrogen, the alien ocean. Deeper still, pressures become millions of times greater than Earth's surface. Hydrogen transforms again into metallic hydrogen. It's still liquid, but now it conducts electricity like metal. Electrons move freely, creating powerful electrical currents. This churning metallic ocean generates Jupiter's immense magnetic field, the strongest of any planet in the solar system. Its magnetosphere is so large that if it were visible from Earth, it would appear larger than the moon in our sky. Radiation trapped in this magnetic field is intense enough to damage unprotected spacecraft. The fuzzy core. For years, scientists believed Jupiter had a compact, Earth-sized solid core, but Juno's data suggests something different. Instead of a sharply defined boundary, Jupiter appears to have a diluted or fuzzy core. Heavy elements, rock and metal, may be mixed into the surrounding liquid metallic hydrogen. This region could extend across nearly half the planet's radius. One possible explanation is a massive early collision with a large planetary body, which disrupted and mixed the core. But computer simulations suggest such mixing should settle over time. Yet Jupiter's interior remains complex and unresolved. The most powerful planetary shield. Jupiter acts as a gravitational guardian for the inner solar system. Its immense gravity attracts or redirects comets and asteroids that might otherwise threaten Earth. Without Jupiter, life on our planet may have faced far more catastrophic impacts. It also emits more heat than it receives from the sun, slowly releasing leftover energy from its formation, and it hosts over 90 known moons. Among them is Ganymede, the largest moon in the solar system, even bigger than Mercury, and Io, the most volcanically active world known. Jupiter isn't just a planet, it's an entire miniature system. Final thought, Jupiter challenges our understanding of what a planet can be. It is wrapped in clouds, filled with oceans of liquid hydrogen, powered by metallic currents, and anchored by a mysterious diluted core. It is not simply a ball of gas. It is a liquid metal giant, a planet that still holds secrets we have yet to unlock. And as long as those secrets remain, Jupiter will continue to stand as the greatest mystery in our solar system.